full IoT platform on a single chip? Today, I'm talking with InnoPhase IoT about a bit of custom silicon they've developed to be an all-in-one machine for IoT applications. But why would you need it when you're an engineer and you can do it yourself? And what makes this chip so good for IoT? Let's jump right in. Deepal, thank you very much for joining me in the studio today.
Yeah, thanks, Edit. Thanks for having us here.
Of course. Well, look, we like what you're doing, but I've got one question just to start it out. You advertise that you're selling an IoT chip. But I guess in my mind, what's the difference between just a chip and an IoT chip? What's the differentiator between them?
Sure.
Whoa, hold there. Only 12% of you are subscribed. Do yourself a favor and subscribe for daily engineering content. All right.
Sure. So, no, that's a great question. So, just for IoT, it stands for Internet of Things. So, basically, when you say an IoT device, it's a device that is connected to the internet. So, it's not just a chip for a standalone function, like if you have a display controller or just a simple Wi-Fi chip. You need to do a function of the complete IoT device and then be able to connect it to the internet securely with the right level of throughput. Again, you need to make sure the device has the right level of power. So if it's battery based, it continues. So it's more of a IoT system on a chip that we work on. Unlike if you just have a microprocessor or just memory or just a Wi-Fi transceiver, we integrate all of this to make sure you have a solution of connectivity right from the sensor, which could be a air quality sensor, it could be a thermostat, or it can be a video sensor, all the way to the cloud. And you do that as an integrated chip and a software.
I was going to say, because most of the time, us engineers, maybe wouldn't need necessarily an IoT chip because, you take your microprocessor, you take the radio module, you take any extra hardware that you need to read in your sensors and deal with the incoming power. But I guess is the reason that you're doing this to make it simple for engineers, right? It's to make it quicker for them to come to market because everything's on one piece of silicon, right?
Yeah. So it's from a time to market perspective. You need a solution that, and as I said to you, if you have an IoT device, it is doing the device function. It needs to connect. It needs to do security. So if you can always do with multiple chips, and then you'll have a lot more touch points and integration time. The software and the hardware integration between the various chips needs to take care of. Now, by offering a single chip, which has a high performance MPU on it, like we do an M33, which has the AI capabilities. We have security built in with hardware accelerators built in, as well as doing firmware authentication and things like that. To the wireless protocols, the Wi-Fi, the BLE, and the Thread and the Zigbee, all combined into one with the rich peripheral IOs that are also integrated into the chip. Not only from a functionality standpoint, this is good and from time to development, but it also meets particular KPIs required for a device, right? You need a device to have a certain performance. You need the device to have ease of use in terms of battery life. It needs to be secure. So it's not just saying, hey, I can do it by 5 chips versus 1 chip, but it's what's required to make it successful. There's a most viable product kind of a scenario that a customer is looking for, an end user is looking for unleashing the IoT experience, making it easy for them to use and achieve what they're trying to do with the device.
Yeah, most of the time on ipXchange, we keep it real with our engineers, right? But since we're already talking about business, time to market, one of the big things that I saw when I was researching you before we had this chat was that you advertise a low cost of ownership of the chip. Mm-hmm. What do you actually mean by that? It doesn't compute with my engineering brain.
Yeah. So the reason we call it low cost of ownership, so there's for any consumer or maybe it's an enterprise, there's a cost to acquire a device or an equipment. There's a cost to operate it, and operate meaning the management, support, things like that, right? So for us, for the low cost of ownership, it's and during the operations also, you need to upgrade the device. You need to make sure it remains secure. So there is a headache. If it's a battery-based device, you have to change the batteries. So it's not just the cost of acquisition, but the cost of operating through the life of the device. And if the device is architected properly, you not only get a lower cost in terms of what you can achieve through integration, as well as the process technology advances, and the patented technology with digital power amplifier integration and the digital radio technology that we have, which makes the device very cost efficient, energy efficient, but also through selecting the right capabilities of the product. So we select standards compliant Wi-Fi, standards compliant Bluetooth, rather than a proprietary RF protocol. So that allows you our device to connect seamlessly with an existing access point,
Yeah,
right?
very
So
helpful.
to use my device, you don't have to go and buy another hub or a gateway to have an end-to-end connection, right? You can just bring your device. You don't need to spend rewiring of the hubs and other things. So there's in the use of an IoT device, it's not just the cost of buying the device from Amazon or say Best Buy, but it's what takes to actually deploy the device in your home or in your enterprise, uh, and then the rest of the connectivity and the operational aspect, right? IoT device, since it's connected to internet and there are security threats, it needs to be upgraded, right? So there's a firmware over the air update required. If it takes half an hour to do it, the consumer is going to say, hey, maybe something went wrong, and keep on rebooting, right? So Wi-Fi with high throughput allows you very fast firmware over the air upgrade, do it securely, so that there's no malignant attacker that can take control of your device. All those aspects bring together the cost of ownership, which if you can lower, it gives a much more value to the consumer or to the business user of the device. So that's kind of
Great.
the holistic integrated thought behind it.
Cool. So what are the typical inputs and outputs of this device? So we talked about Bluetooth and Wi-Fi before. So those are our outputs or even inputs
Sure.
to get data off our device. But what are our typical inputs? So we've got all of the ADCs that we could ever want. We still have IOs available to us, USB ports, etc.
Sure. So the idea is to uh, take the data from the sensors that are out there and then connect to the internet, right? So there is
Great.
various kinds of inputs required depending on the kind of sensor you have. So you can have typically your I square C bus or an I square S bus. You want to connect sometimes to a high performance video chip to this chip so that you can have a complete
Oh,
camera
it's
or a video
capable of
doorbell design. Sorry.
it can process video.
Yeah. So we don't process the video, but we connect to a chip that can process the video. Again, as I said, we look at a complete system device, IoT device solution. So the connectivity to the video chip would be through an SDIO or SPI bus. You can
Yeah,
connect
yep.
through external MCUs with UARTs. So essentially, and then of course we have analog inputs like ADC for certain other kinds of sensors, temperature sensing, and so we want to make sure we connect to occupancy sensors, air quality sensors, and also image sensors and video sensors, right? So we can connect to the SPI bus to do a person detect right on our chip. So we can then pick up the video chip if required or not. So we can do smart power management by having image sensors connect to our chip also.
Great. So often, getting a piece of silicon from you and putting it straight into a design can be a bit scary, particularly if, you're considering other options. Do you offer dev kits? How easy do you make the experience for the engineer actually
Exactly.
putting your chip into a product?
Right. Yeah. So as you may know, chip industry, you can't just sell a chip like that. You need a complete reference design or evaluation kit. So we do have an evaluation kit, and since we do MCU connected with wireless technologies, it's very difficult. A lot of the RF expertise may not be there with everybody. So we actually make a reference module which has our chip, the flash, as well as the RF components all built into one, and then that is put on the evaluation board. So you don't need to worry
Hmm.
about FCC and the certifications and all that. It's all taken care of. We have a
Great.
way to program the chip through either a PC or through a different programmer board. And then we have jumpers and connectivity solutions out there, so you can connect and scale the platform to other external devices, and you can test the whatever I'm saying to you or whatever we broadcast on our website or whatever. You can actually measure the power, you can measure the performance, you can measure the throughput, the range, the various protocol capabilities. End-to-end solution from sensor to cloud is what we have. Sample apps that comes with the eval kit. So it's a complete solution, not again just the hardware of the eval kit, but the OS and the firmware protocols, the APIs, and the middle layer and the upper layer sample apps, right? So that you can,
Great.
in a couple of hours, you can check the device out and see if it meets your requirements.
Awesome. Easy. I didn't even ask. What is the name of your device?
We call it Talaria. That's the IoT platform
Talaria.
that we have. And then we have various devices within the family. We have Talaria 6 single band, which we call INP 6120 is the code name, but the family name is Talaria 6. We have Talaria 6 dual band that will be sampling later this year. The Talaria 6 single band is already sampled. And Talaria 6 we call it because it has the Wi-Fi 6 capability, and also some of the Wi-Fi 7 capabilities are built into it. We also have a Talaria 4 which just does Wi-Fi 4, so people who don't want Wi-Fi 6, they can. But again, the complete architecture is there across the family with the high performance MPU, with security built in, with connectivity to the sensors, with multi-protocol support, multi-band support. That's all there. But then, depending on the capabilities and the power and the trade-offs people want, you can have a Talaria 4. We actually have Talaria 2, which is already in production for the last 4 years, with modules and customers across in the smart home, industrial IoT, medical devices, building automation. The same customer base will remain, but this has a much richer offering and a richer family portfolio of products that we are bringing to market this year.
Awesome. Deepal, thanks very much for joining me in the studio today.
Yeah, thank you very much. Nice talking to you.
It was great to learn some more about the Talaria family from Deepal. Feel free to navigate over to our website where we'll have the full data sheet and write-up for you to learn more. Like, subscribe, and until next time, stay disruptive.